Let's continue looking at compound inequalities with graphing compound OR inequalities. So in the last video we looked at AND type or intersection inequalities, and now we're going to look at the OR type, also known as a union. These inequalities work a little differently but pretty similar. So again, compound inequalities are two inequalities that are put together. Now, OR inequalities are true if either inequalities are true. So you know a number is a solution to a compound OR inequality if it satisfies either of the two inequalities. So when we did AND inequalities, it had to make both of the inequalities true. But here for OR, it only has to make one or the other, not both. If either is true, then the number is a solution. So it's actually a little easier to graph these because you don't have to worry about overlap. We're just going to shade both inequalities on the same graph, and they do not need to overlap. Right? So it's not necessary for our graph to be only where the two inequalities overlap. We're just going to put them both on the same graph and kind of see what happens. Again, these are also called a union because we're just putting both inequalities together, both of their solution sets together, and not really worrying about any overlap. So let's try it. We have x is less than -3 or x is less than or equal to 5. So the way I always have students start this is you put the numbers on the graph. Okay, so we have -3 and 5 here. For x is less than -3, we'll use an open circle. And then it's less than, so we'll shade to the left. So there we go. So notice I'm not checking ahead of time. We don't need to know where the other one is yet. Now the other inequality is x is less than or equal to 5. That is a filled in or closed circle. Remember that shows that x is also equal to 5, not just less than. So it has this underline here. We're going to use a filled in closed circle. And it's also less than or equal to, so we're going to shade to the left. And you see it will kind of overwrite that -3, and that's fine. So this is our solution set here. Any number less than or equal to 5, it overlaps over here in this area, but that doesn't matter. If this was an AND type, we would only have shaded here. But since it's an OR, we just put both on there. All right, let's try example B. Greater than or equal to 3 or x is greater than 6. So you can kind of see this is going to be similar. Greater than or equal to 3, that's going to be a filled in circle at 3. And then shading to the right because that is greater than, so shade to the right. And then x is greater than 6. It's an open circle, but it doesn't really matter at this point because we know that it was kind of shaded by the other inequality. And greater than 6 means we go to the right as well. So that second one was sort of taken care of. It's included in that first one. So there you have it. So if a number is either greater than or equal to 3 or greater than 6, it is in the solution set for this compound inequality. Looking at example C, we have x is less than -4 or x is greater than 2. So put the numbers on there. We got -4 and 2. Less than -4, that's an open circle, shaded to the left. Okay, and then greater than 2, it's another open circle, but greater than, so shade to the right. And there we go. So you notice these don't overlap at all. If this was an AND inequality, this would be no solution. But because it's an OR a union type inequality, it's okay. So the numbers that make this one, that are solutions to this one, are either the numbers less than 4 or greater than 2. All these numbers are part of the solution to this compound inequality. Okay, last one, greater than -1 or less than 8. So we'll put the numbers on here, -1 and 8. Greater than -1, open circle, shade to the right. Less than 8 is also an open circle, but again, it's been shaded by the other one. And then less than to the left. So you can see what happened here. We actually ended up shading the entire number line. And so what this means is every number is either going to be greater than -1 or less than 8. Every number fits one or both of those inequalities. So for this kind of situation, the whole thing is shaded. This is actually a solution set of all real numbers. I know we're used to, in algebra, having, if it's not one solution, it's usually no solutions or infinite solutions. But in this case, every inequality that we're shading, these all have infinite solutions, right, because they go on forever. So it's not specific enough in this case to say infinite solutions. So instead we just say all real numbers. The entire number line is shaded. Every number on the number line is a solution to this compound inequality. Okay, so there you have it for compound OR type inequalities. Just shade them both on the same graph. Don't worry about whether they overlap or not, because it doesn't matter. The inequality is true if either of the inequalities in the compound inequality is true.